Sai Ram. Having seen about the Dalton's theory where he brought about ideas regarding atoms, molecules and elements, the moment we start slowly studying these aspects, measurements will come into play no sooner than later. So the moment these measurements come into play, you have to give proper units to the measurements which have been present. What are the various measurements that we undertake? If I have to weigh my body, I will take it in terms of kgs. You must have heard this part. If you are traveling from one place to another place, somebody says Bangalore to Mumbai is around probably 1000 kilometers or so. What is that kilometer? That is the unit that we utilize. So this as a standard form, we'll be studying it in this part here, which is under SI units. Now the abbreviation is SI, but this is the name system internationally, where this Latin name has been utilized in the 1960 General Conference that was held regarding the weights and measurements. So in that General Conference in France it was held, and there this system has been proposed with basically the French naming that we have called Lay System Internationally D units. From that we are going to utilize the English version of it for our day-to-day uses which have been there. So what they have done there is they are given 7 basic units, and from that basic units you can still derive large number of units which have been present. So what is this basic unit, the theory of all this? Let us just see here. In a tabular form you are given various physical quantities, name of those and the symbols that have been given here. Length is measured in terms of meter and the symbol there given is m. No doubt when you tell about large distances, you generally tell it as in kilometers. But the basic length measurement is done in meter. Now at times you also talk about centimeter. Whenever you have to use a scale, normally you have around say 15 centimeter or 30 centimeter in it. See, all these calculations are possible, but this is the basic unit that we use for measurement of length. Mass. Now please understand here that for mass they didn't use gram in that similarity. Rather the basic unit used there was kilogram in terms of kg. Now because generally mass in larger quantities come under kilogram measurement, whereas length, because it has to be measured from place to place, they have considered it as meter. There is no hard and fast rule in this. It is just that in that conference this is what was considered. Time measured in second, S, minutes, hours, everything we have, but then this is the basic unit. Electric current, ampere, this is the unit that we use. Temperature, once again we use it in Celsius also. Generally our room temperatures are around 25 or 30 degrees centigrade. You go to hotter places, it goes up to 40-45 degrees centigrade also. But the measurement unit which we are using is in terms of Kelvin. We also have another unit called as Fahrenheit. Amount of substance, mole. Now this study you are going to do extensively in this chapter. Amount of substance. What is this amount of substance? Let's see in the further parts. Whereas luminous intensity, this you are going to study extensively in physics, where it is the unit is taken as candela, where luminous intensity is nothing, dealing with the light years, measurement of distances from our earth to various stars and all. So I think as of now you are very much aware of these 3 physical quantities used in day-to-day life. These 2 also you do come across, electric current and temperature you do come across, and these are the units. These 2 for now let's just keep it aside, because this anyhow we are going to study luminous intensity. You will be studying it in physics part. So these are considered as a basic 7 units, and from these basic units you can derive other physical quantities also. For example, this was meter. Now, how is speed measured? What is speed basically? So suppose if I tell that if I go from Muddanahalli to Bangalore, which is the distance is coming around say 70 kilometers, and if I am for that 70 kilometers, if I am taking 1 hour 10 minutes, which I can call it as 70 minutes. Now how do I calculate the speed there? Generally I consider that I have traveled the distance of 70 kilometers, and if I have to talk in terms of minutes, I will take that I have gone at the rate of 1 meter per minute. or say kilometer, because we generally measure it in terms of kilometers. So if this is how I represent 70 kilometers, if I have traveled in 70 minutes, the speed I'm going to represent it as 1 kilometer per minute. What you understand here is that you have utilized the basic units only. Minute, the basic unit was second, you have just used a higher version of it. Kilometer, the basic unit was meter, you have used a higher version. So basically for speed, the unit that we use is meter per second. This is one way to write, or meter second per second. This slash tells per. What is this per? It indicates that this distance is traveled in so much of time. What is important to be understood here is that these are all the basic units. This we call it as the derived units. What do you mean by derived? Something is already there, from that you are getting another unit. Meter is here, second is here, from that you got the unit for speed. So this is how we understand about the various SI units that are being utilized, and this is how various measurements are done. So generally when you undertake measurements, general measurements are fine, but very large and very small measurements, you will have to adjust your count also relative to that. And that is what we see here, is that generally we have various symbols as such. So for example, we have meter for measuring length. Now if the distance is pretty far, we use this kilometer because it has gone to a large extent. Or if the distance is very less, we also have millimeter, we have centimeter, then we have meter, we also have a factor called as kilometer. There are actually many more things also. After that kilometer also there are many more things. Before millimeter also there are many more things. So what we try to understand here is that there could be one important basic unit. To that, various multiples could be present. So as an example, you have it here, 1 kilometer. Now what is kilo? Kilo essentially is 10 raised to 3. That is what is the terminology of kilo, kilogram, kilometer. So you can understand that one factor where if you multiply it by 10 raised to 3, that is coming under kilo factors. So therefore 1 kilometer can be equivalent to 1000 meters. 1 kilogram is equal to 1000 grams. So this is the way for representing. This is for larger quantities. You can also see some smaller quantities being represented in these cases. So what are those smaller quantities? 1 centimeter. We know very well that 100 centimeters is 1 meter as such. So what is being done here is just the reverse of that. Just to extrapolate this concept here. So we know very well that 100 centimeter is equivalent to 1 meter. This 100 centimeter, I can actually write it as 10 raised to 2 centimeter is equal to 1 meter. So what is this 10 raised to 2? 10 raised to 2 indicates that 2 tens are multiplied. 10 into 10, which is nothing but 100. If it was 10 raised to 1, it means just single. Then what do you mean by 10 raised to 3? It indicates that it is 10 into 10 into 10. And that is what was used here. 10 raised to 3 indicates it is 10 into 10 into 10, which is equivalent to 1000. So now the same thing, just to have a general understanding about these parts, what I am taking here is that 100 centimeter is 1 meter, which I can also write it as 10 raised to 2 centimeter is equal to 1 meter. The same thing if I can send it on the other side. Now since this is 10 raised to 2, if I divide that part, I can write it as 1 centimeter is equal to 10 raised to minus 2 meter. Now how did this come about is that this factor, where multiple factor will then become divisibility factor on the other side. We have studied about reciprocals and all, where the change in multiplication, the opposite factor of that is division, and therefore this is how the conversion takes place. If you are going for millimeter, milli indicates, while kilo indicates 10 raised to 3, milli indicates 10 raised to minus 3. So these are some of the conversions which are shown here. Here it was shown in terms of distance generally, kilometer, centimeter, millimeter and all. You can also go for grams, kilograms and other factors as such. So just to study this part in a more clearer way, as I told you, there are things on either sides of kilometer and millimeter. So we have many things here. If you see, so this is the one 10. So if you generally see 1 which is there, if I consider that as the basis, so here if I take it as 1, so 10 raised to 1 indicates is equal to 10. This they tend to call it by a name deca. Now what they have done here is, for explanation they have used meter as the basic unit in this cases. So this is deca. Then the second one, if you see here, 10 raised to 2, which is actually equivalent to 100, because 10 raised to 2 indicates 10 into 10. So I can write this as 100. Hecta. Then we have kilo. Now this is something that we are very much aware of, kilometer as such. You also have other units, for example mega, giga and tera. No doubt there are other factors also, 10 raised to 4, 10 raised to 5 and all, but generally these are given special names. So 10 raised to 6 is called as mega, giga and tera. So these things have to be known to you and should be clear to you. Now, please understand that all these three are in capital letters. The symbol capital or small is very important, because many things we try to represent, and this change in the size that determines. Why I tell this is because if you just come down, while 10 raised to 10 was deca, 10 raised to minus 10. Now what does this 10 raised to minus 10 mean? 10 raised to minus 10 means 1 divided by 10. Please understand, 10 raised to 1 was nothing but 10. 10 raised to minus 1 is 1 divided by 10. 10 raised to 2, that is the hecta form which was shown here. If you see this 10 raised to 2, it was nothing but 10 into 10. Whereas the 10 raised to minus 2 is nothing but 1 divided by 10 into 10, which you can also write it as 1 divided by 10 raised to 2. So that divisibility factor, if you want to show it in multiplication, once it goes up, it becomes 10 raised to minus 2. Because if it is 10 raised to 2, then it means that it is on the numerator. This indicates that it is on the denominator. What is important for you to know is the name also that is present here. 10 raised to minus 1 is deci, deca, deci. You can see the symbols variation also, because since you cannot give the same symbol, these variations are seen. This has to be clear. Centimeter, this is something that we have utilized many a times. cm, we tend to write it in general cases. Millimeter, now once again, mega was given as capital, milli is given as small. So this factor is very important. Like the way we also had 10 raised to, in the upper parts, 10 raised to 6, 10 raised to 9, 10 raised to 12 and all. Similarly, we have this in the negative forms also, where we have 10 raised to minus 6, 10 raised to minus 9, 10 raised to minus 12, which is given as micro, nano and pico. Along with this, in chemical studies, you are also going to come across one part which we term it as Armstrong. It is based on the name of a scientist, Armstrong. This is how we represent it. One A we write and then one small o of sorts. Now what is this Armstrong is? It is 10 raised to minus 10. So generally you can see that the factors are 10 raised to 1, 2, 3 and then it goes 6, 9, 12. Similarly in the negative parts also, if you see, it is 10 raised to minus 1, 2, 3, then minus 6, minus 9, minus 12. This is one special factor where in chemistry we use it generally, which is called as Armstrong, which is 10 raised to minus 10. Just see the namings that are being shown there. It is dependent on this part there, terameter, gigameter, megameter. If it was in gram, you would call it as teragram, gigagram, megagram. Similarly here, milligram, microgram, nanogram. So it all depends on one prefix. Prefix means what? Before. Suffix means afterwards. So our basic unit is meter. So to that basic unit, we have certain prefixes, mega, giga, tera and all. Suffix you are not going to come across in this case. So this is how some prefixes that are being used along with the SI unit, so that you are able to account for very large calculations. Also, you are able to account for very small calculations also. So this is all about the SI units and all that we have, and a small assignment just for you to brush up whatever we have discussed. Name the SI unit of mass. SI unit is important. Will you name it as kilogram? Will you name it as gram? Will you name it as milligram? Be careful with that. What symbol will represent 1 into 10 raised to minus 6 gram? Symbol. So basically that prefix part along with the unit. Now one unit is already given here, that's fine, but along with the unit it is important. Name the prefixes for 10 raised to 2, 10 raised to minus 9. This is more conceptual, you just got to refer the periodic, the table which was there. But please be aware that these things you will have to have it in your mind in your long run studies. What do the following symbols represent? Be clear how it is represented. Capital M small s, small m small s. What do these indicate? So this you have to be careful, because as I already told you, whatever symbols we give, whether you write it in capital or small, matters a lot. So this is all that we have for this part, and with these basics we will go further in the study of the chemical atoms and molecules and its various properties. Thank you. Sai Ram.